boundary condition for using the variable, and here this is another parameter E. E is the conjugate parameter, and the present in distribution we consider P equal to 1. Here we use the side system function, iterate the similarity variable, and H theta is the surface temperature and H is the dimensionless temperature. Then we use this, we get the two equations. The first equation, the equation 12, is represent the momentum equation, and second is energy equation. Our present result compared with the Koji and Dupo and Martin and Paul, we observed that this table, our present more closer to the Martin and Paul. Results and discussion. This figure is thermal conductivity variation, velocity of thermal conductivity variation, and temperature of the thermal conductivity variation. Here, gamma equal to del Tb minus T infinity. Gamma depends temperature difference between temperature outside of the surface and temperature of the outside of the fluid. Gamma depends on this temperature difference. When gamma temperature difference increases, then gamma is also increases. That means the heat moves from plate to the boundary layer. Then it increases the temperature increases within the boundary layer, and rapid mass transfer. That means the velocity increases. We also seen that the velocity increases for the increasing thermal conductivity variation parameter, and temperature increases for the increasing thermal conductivity variation parameter. As a result, we observe when the velocity increases of thermal conductivity variation parameter increases, then the skin friction increases for the increasing value of thermal conductivity variation parameter. And when as a result, surface temperature increases for the increasing values of thermal conductivity variation parameter. This is the velocity profiles against N for the viscous distribution parameter. Here we observe the velocity increases for the increasing values of viscous distribution parameter, and as a result, when the increasing velocity increases for the increasing values of thermal conductivity viscous distribution parameter, as a result, we observe the skin friction skin friction increases for the increasing viscous diffusion parameter, and surface temperature increases and increasing values of viscous diffusion parameter. Here, this is the velocity against theta for Prandtl number. Here, Prandtl number is represent the kinematic viscosity ratio of the kinematic viscosity and thermal diffusivity. Prandtl number is a proportional to the viscosity. That means that when the Prandtl number increases, then viscosity increases. So viscosity when the viscosity increases, then the velocity decreases. That means when the Prandtl number increases, then the velocity decreases. We observe the figure. That decreases velocity for increasing values of Prandtl number. When the velocity decreases, then we observe that the skin friction decreases, and also surface temperature decreases. Conclusion: the velocity and temperature within the boundary layer increases for the increasing value of thermal conductivity variation parameter and viscous diffusion parameter, and decreasing values of Prandtl number, and skin friction of increases of the increasing values of thermal conductivity variation parameter and viscous diffusion parameter, and decreasing values of the Prandtl number. The surface temperature increases for the increasing values of thermal conductivity variation parameter, viscous diffusion parameter, and decreasing values of Prandtl number.
Thanks for presenting, and I would like to ask the audience for any questions, please. Which are the fields which is applicable in this particular topic? It is applicable which are on the fields? Applications. Which are some engineering something you can say, please.
We apply the heat transfer for the freeze and cooling of the room. That is, we can apply.
You are mentioning about the CF values, no?
CF.
Yeah, there's a, that is a frictional, that CF plots you are showing in some of your graphs. CF values. Skin friction, no?
Skin friction.
Have you ever discussed the Hughes results? Because you discussed Prandtl, Hughes Prandtl are coming to
Prandtl number.
Yeah, Prandtl number you have discussed, but Hughes work are
viscous diffusion.
Yes.
Viscous diffusion, we include the viscous.
Because the CF values
viscous diffusion include the energy equation. So gain to the energy. When the energy increases, then we observe the velocity increases